Okay, so we are doing number 3 of 1.5. That's page 39. So we have a helicopter. This is not a very nice looking helicopter. Yes. There you go, helicopter moving west. It starts at a velocity, right? So I like using acceleration at t1 was such and such. So we'll say acceleration at t, we mean velocity, sorry. Velocity at t1 starts and the chopper goes at 7 meters per. Oh, that's the acceleration. So sorry, 15 meters per second. And it's going to increase from that moment at t1, so t0. I should actually call that t0. Just fix that. And from t0, so acceleration, I'll call it the total, right? Throughout, it's a uniform acceleration. It's going to accelerate at 7 meters per second square. Oh, it's going east. It's going east, so it's going to slow down. Okay, that's a good question. So that acceleration, I should put my directions on this. This is west. This here is east. Right. That's for 4 seconds. Okay. Okay, so let's think this through. So it's going west, and the acceleration is east. So if we do a quick velocity graph, it's going to have this general shape. Now, we know that it's an acceleration that's uniform, so that means that, but it's a negative acceleration, right? So I can actually just redraw that, rewrite it as being -7 meters per second square, but now it's west. Or alternatively, we could switch this to a negative velocity going east. It makes no difference for us. So we'll just assume that this is, that this is west here. Okay, so if it's negative acceleration in the direction of west, that means, and it's uniform throughout time. So, right, if I had, now the issue is just that it's going to decelerate, but if I have an acceleration that's positive, let's say that that was acceleration, like this, right? That means my graph in terms of velocity, if I'm going backwards like this, it would look like this, right? Now we know it's slowing down, so it's just going to do the opposite, right? So instead of going like this, it's going to go down. So that means my acceleration is not going to be here, right? It's going to be under, because it's the negative. We have it here. It's negative. Okay. So, what about I erase my couple of last drawings? It's just this line I need out, right? So we know it's going to be a negative acceleration. So it's going to go here, and it's at -7. Right? So if I extend this line, this is -7. My units for this is acceleration. This is meters per second square. Just for the sake of clarity here, I'm not going to draw them. So if like this gave me a positive acceleration being down, that means that my line for velocity is going to go down. Now, what we don't know is it would make no sense that this helicopter reaches a velocity of 0, right? Actually, it's a helicopter, that's true. It's not a plane. A plane, that would be critical. So the question is asking, what's the final velocity of this plane, of this helicopter, so sorry, after 4 seconds, right? After 4 seconds, that's an S. Okay, so basically, we just try to go backwards using the area, and it's going to tell us the velocity, basically, that we have, that we will be left with. Now, we start with a positive velocity. It's at 15 here. So we're going to have to minus from this number. So that means that this helicopter could well end up actually stopping and then starting to go backwards. Is it possible? Let's look at it. So we're really just going to find the area up to here, because remember, going this way, it's the slope that you use, delta y over delta x, but going, oh, sorry, it's outside of my range. Going this way, that's my area. Okay, so what are we left with? We do a bit of math here. We find the area of this region. Very simple to find. Minus 7 times 4. Oh, sorry, it'll work. Times 7. I just made a mistake, but it works anyway. What is that? That's negative 28. Now, what have I found? Have I found acceleration? What have I found, right? We said basically going down this way, going back in graphs, I'm getting what I need to change my y value by, right? So I'm going to have to go down by 28. That means that this helicopter, by what I'm seeing here, is actually going to go backwards now. And that means that it was stationary at some point here in the middle, but just for a fraction of a second. So you just do 15, and you're going to minus 28 for that, from that. So it's 15 plus negative 28. 15, so that's going to be 13, if I do my math right. So that means that this helicopter, so my line here was wrong. It actually lands at 4 seconds. If I stop here at 14, this is going to be messy, but 13 would be around here on this graph. So that means if I use another color, we have this available. Might as well use it. Which color should I use? Green, this way. Okay, so if I go back here, so negative 13, they're going to overlap here. I didn't expect it to go negative. So negative 13 would be about here, right? So if I connect to here, sorry, this is not easy. Okay, so what I've been here, crossing, so the helicopter being stationary. So my final velocity is negative 13. So velocity at 4 seconds is negative 13. Now don't forget your units, so meters per second. I just want to confirm in the book if I did that right. So nine. This is the time to get anxious. Oh, I was dead on because it says east. Oh, I forgot my direction on this. No, that's right. Let's work on the mouse pad. Yeah. So this is negative 13 meters, but that was west, right? Because my referential, I transformed it into west. Okay, so we were right on. Perfect. Okay, that's good news.